that's a lot to write down. But at least you have one example that you can put in your notes so that you can look back at this while you're working tomorrow if you need to. Okay, I'm actually going to draw a visual. I'm just going to slide this up a little bit, so if you're still writing, you'll have time here. But I'm just going to draw a picture, because I'm more of a visual person, right? I think I've said that enough times here. But it helps me to have a picture to go with this. So I'm just going to draw a parallelogram. Okay, so let's just be clear as to what we're talking about here. It says the measure of one interior angle. So pick one of the angles, the measure of one of them. Okay, so let's say we're talking about this one. The measure of this angle is 30 degrees more than 5 times the measure of another angle. Is it talking about this angle is the one and then this is the other one? Would this one be 5 times more than this one? No, they'd be equal, right? So we're not talking about the ones across from each other. We're talking about the two that are next to each other. Okay, so one of them we don't know, and the other one we know is 5 times plus 30, plus an additional 30. So we're going to label one of them as x, because I don't know it. And then the other one is 30 degrees. This is how you actually write more than and less than. The plus and the minus actually go at the end. So it's actually more than 30. So 30 degrees more than 5 times that other angle that we don't know. And if we can get this picture, do you know what to do with those? This is from yesterday. Do I set them equal? No, they're not equal. So the other option is you either set them equal or you add them to be 180. Those are your two options. So this one is going to be add to 180. So we're just going to take these two angles. So 5x and 1x is going to be 6x plus 30 equals 180. So we're going to subtract 30. So it's going to be 150. Divide that by 6 and you get 25. It does say find the measure of each angle. So we got lucky because one of our angles here, this is definitely 25, right? Okay. So you can just use the fact that you know they're supplementary. So if one of them is 25, then the other one is 180 minus 25. But you might want to just check and make sure that when you plug 25 back in, you actually do get an angle that's supplementary to the other one. So 5 times 25 plus 30 would be 155. And is that supplementary to 25? Yeah. So this is 155. Okay, so we just introduced this problem today. I have one more to show you tomorrow, and then you have one to practice yourself tomorrow on the practice test. And if there's some part of this you're just like, wait a minute, where did that come from? Just make sure that you just say, hey, why did we write this down? And I can help you out with that. Okay. Okay, now let's actually get on to our actual notes for the day. So I'm going to slide this over. So if you didn't quite get that, don't worry. We're going to show another one tomorrow, and then you'll have a practice one as well. Use this guy. Okay. So we actually already did this first one here, the coordinates of D. Okay. Let's just take a second. We're going to do this part right here. So you already have yours graphed. Where's mine? It's already graphed. There it is. So it should already look like this. So we're going to draw in the diagonals here. And we're going to just talk about something really quick that's going to help us on our last problem here. So go ahead and draw in your diagonals for AC. You already have the picture, so we're going to draw in the diagonal. And then we're going to draw in that diagonal. It says the diagonals intersect at the coordinates of P. So the coordinates of P right here would be, now if you drew your lines true, like they were actually straight lines, they should intersect at a nice point. Okay, so mine intersected at 1, 3. Yours intersect at 1, 3. So those are the coordinates of 1, 3. Okay. I just want to talk about, because it's going to help us in a second, I just want to talk about what does that mean? Like, what is the coordinates of P in this picture? So when you draw in those diagonals, let's be intentional about how we do that. Isn't it true that this is congruent to this? So for P in the coordinate plane, what do you call that dot? For AC, P is the, what kind of a point is it? Yes, and what point would be right? Midpoint. The midpoint, right? So one of the things that you can do to find point P, let's say we didn't have point P, we didn't know anything. How could we find point P in the coordinate plane without having a graph? Super easy to find with a graph, right? What if we didn't have a graph? We could find it using the midpoint. So one of the things, keep this in mind, how could we prove, because this is where we're going, how could we prove or how could we find P? Just remember that P is the midpoint of AC and also the midpoint of BD. So it's the midpoint of both. Keep that in mind as we move forward today, because that's going to be important as to where we're going. Okay? Okay. We're going to skip over this one for now. We're going to go down here. And this is where we're at today. Here's the difference between yesterday and today. Yesterday I said, this thing is a parallelogram. I need you to tell me what's true about it. Today, we're going to go backwards. I'm going to tell you something, and you're going to tell me if that makes it a parallelogram or not. Okay? So, let's just go back to yesterday. Yesterday, I said we have a parallelogram. What was true about a parallelogram? Tell me any property you remember from yesterday's parallelogram stuff. You can even cheat and look back, right? So you wrote them down. What is one property that is true about a parallelogram? Just shout them out. Go. Opposite sides are congruent, and then we have opposite angles are congruent. So all we're doing today is we're reversing that. So I said, if I have a parallelogram, then you're allowed to say opposite sides are congruent. So reverse that. If opposite sides are congruent, you're allowed to tell me that it is a parallelogram. That's not too difficult, right? It's a converse. Why did we learn converse? This is why. So we're just reversing all of the things we learned yesterday, but we're adding one more. Okay? So these are the 6 ways to prove that something is a parallelogram. So if you have one of these 6 things, then you're allowed to say it's a parallelogram. Okay, that's what we're doing. So if. So here's the 2 that we already shouted out. So if opposite sides are congruent. So that would be tick marks. Sorry that there are the parallel markings on here. So tick marks. We'll just change those up to tick marks. So if you see that, we get to say it's a parallelogram. It may not look like that. It may not have tick marks on it. Maybe it'll just have numbers. So maybe it'll have 8 and 8 and 15 and 15, right? That would also be the same. Okay? We also heard opposite angles are congruent. So opposite angles are congruent. That would also tell us that it's a parallelogram. So if it's got markings here and here, or they don't have to have markings, it could be numbers showing you that the opposite numbers are the same. Okay, what else? What else do you remember? Anything? Sides are parallel, right? That's the definition. The opposite sides are parallel. Okay, that's the definition of, so that one counts. If you see opposite sides are parallel to each other, then it's a parallelogram. They can trick you with this one, however, just want to give you a heads up on that. To say that they're parallel, they don't actually always have to mark them parallel. They will on these ones that you're going to see. But they could also show you that alternate interior angles are congruent, and that would mean that they're parallel as well. Okay, what else? What else did we learn yesterday? What are the other properties? It's on the sheet there. You can cheat, look back. Yes, consecutive angles are supplementary. Consecutive angles are supplementary. And I shorthanded that. Consecutive angles are supplementary. There is no way to mark this. They have to give you numbers. Okay? And more importantly, they have to give you 3. They don't have to give you all 4 because they should add up to 360, right? But they have to give you 3 numbers. If there's not 3 numbers, you do not have all the sides parallel. So 180 is the ones next to each other, but all 4 of them would be 360. Okay? So they would have to give you like 120 and 60 and 120 because that would give you both pairs. Okay? So you might want to make a note to yourself. They have to give you at least 3 of those. They could give you all 4. That's fine. But they have to give you 3. Okay? There's only one more. It's about the diagonals. We just talked about it. Diagonals. What's the word?
Bisect each other.
There we go. Diagonals bisect each other at the midpoint. Yes. So the diagonals bisect each other. And it has to be both, right? It can't just be one. It's got to be both. Bisect each other. Because if we're not specific about this, it actually means that it's a different shape. Okay? So if it's not both, so they have to put the diagonals in there. And they can give you numbers. I don't like it when they give you numbers because the pictures are super hard to write numbers on. But if they give you this was 5, and this was 5, and this was 7, and this was 7, that's it. Diagonals are bisecting each other. So what you're going to be doing is you're going to be looking at a set of pictures, okay? And from those set of pictures, you have to say, are you looking at a parallelogram? Yes or no? Okay? Okay, so what's actually going to show up on the homework today, though, is going to be, okay, these all are parallelograms. What picture or what theorem are you using or what property is being shown here? Okay, so that's what you're going to do. There's one more. Okay, and the reason that there's one more is because you could have kind of a mixture of these things and it would still be forced to be a parallelogram. Okay, so the reason is, let me get the markings on there. Pick one pair of sides, and I don't like this picture because this picture is already marked with the parallel lines business. So I'm going to redraw mine underneath here where it's not marked. So sorry about those pictures. If you have one pair of sides, one pair of sides that has both parallel markings and congruent markings, that is also going to force it to be a parallelogram. Okay, let me show you what that looks like. Pick a pair of sides, either the top and bottom or the right and left, and you're going to put both markings on there. So on the top to bottom, it's going to have a congruent and a parallel marking. The bottom is going to have a congruent and a parallel marking. Okay, and so there, I just didn't like the picture up top because it also has the parallel markings on the side, so that's why I didn't use that one. Okay, here's a little be careful of. Okay, so be careful This one does not work if they are marked opposite, like one of each. This is not. This does not count. Those two markings have to both be on the same side. If you're wondering why that is, we have a shape coming up later on in this unit where its sides are congruent to each other. The top and the bottom are parallel. That's not a parallelogram. It's a trapezoid, right? So that's why that doesn't work, to have one on each side. They have to both be together on the same side in order to make it a parallelogram. Okay, so let's see what it's going to look like. Slide over here. So those are your 6 options. Okay. So what you're going to be doing on your homework, the first part, is you're just going to be giving a name to the pictures. Are the pictures actually parallelograms? They all are. And you're just going to be stating which theorem or which property are you looking at. So all you have to do is write one of the 6 things that we wrote down. So you have to pick, is it opposite sides congruent? Is that what they're showing you? Are they showing you opposite angles congruent? Are they showing you opposite sides parallel? What are they showing you? Okay, so just pick one of those and we'll put that on each one. So all you're writing down is one of the 6 properties. So here, they're showing you that both of these are equal. So they're showing you one pair of sides both parallel and congruent. That's the longest one to write, so don't worry about the other ones being quite that long. But that's all you're doing. You're just saying which one of the 6 are they showing you in this picture. Number 2 is a trick question. Which one are they showing you? There's 2 options, right? They're showing you consecutive angles add up to 180, but they're also showing you opposite angles are congruent. It doesn't matter which one you write down. Okay? You just pick one. And you can shorthand opposite angles congruent to each other. And then the last one, of course, is opposite sides congruent to each other. Okay, so right now all we're working on is recognizing the properties, because we are then going to add on to this when we get to the rectangle, rhombus, and square properties, and you're going to have to be able to look at a shape and say specifically, is it just a parallelogram, is it a rectangle, a rhombus, or a square? That's where we're going on the test. Okay. Okay. This next part is really just more practice from yesterday. Okay. But they're just making it tricky so that they're throwing it into this section. So let's look at the directions. Does it say that it's a parallelogram? No, it doesn't say that. It says, what value of x would make it a parallelogram? Well, it's showing you that these 2 are congruent, but it gives you these 2. It doesn't say those are congruent, but you want them to be congruent if you want a parallelogram. So you just set them equal, just like you did yesterday. Okay, so it's a tricky way of bringing the same problems from yesterday into today's lesson, because it didn't necessarily tell you it was a parallelogram. But if you wanted it to be a parallelogram, you would just set them equal and then solve. And then same thing for the other one. So it's going to have the same couple of problems from yesterday to kind of just reiterate some of the properties again. Okay, so those are the first 2 sections of your homework. Pretty straightforward, pretty easy, and also really just reiterating what we talked about yesterday. Okay, let's look at the very last type, which is on the back here. You need to show me that this thing is a parallelogram. Okay, there are 6 ways to do that. Some of them are not possible in the coordinate plane. For example, it is really difficult for you right now to tell me if the opposite angles are congruent to each other. That's kind of not an option. It's really difficult for you to tell me that the consecutive angles add up to 180 because you don't have any angle measures. But here's what you could do. You could show me that the opposite sides were congruent by using the distance formula four times. Sounds like fun, right? No way. Okay, that doesn't sound like fun. So that is an option. We can do that. And especially now that we know the Pythagorean theorem and we're really good at the Pythagorean theorem, the distance formula is not actually that difficult. So let me just show you that really quick. So if we were doing the distance, we would just make a right triangle. 1, 2, 3, 4, 5. 1, 2. So this is a 5, 2, and then this is what we're actually looking for, so that would be x. So to do the distance formula, you could really just do a quick Pythagorean theorem with 5 and 2. Okay? And that would give you the distance. So you could do the distance formula 4 times to show that the opposite sides are congruent. You could do that. That would be one way you could do it. Okay? A second way that you could do this, and this is what we kind of talked about at the beginning, is you can show that the diagonals bisect each other okay? And we will be doing a lot of this very specifically when we get into the rectangles, the rhombuses, and the squares, but this is kind of just introductory to it. You could show that the diagonals bisect each other by showing they have the same midpoint. If the diagonals have the same midpoint, that means they bisect each other. You could do that as well. Midpoint formula twice, that's not as bad as doing the distance formula 4 times, right? But wait. But the easiest way to show that this is a parallelogram, okay, one of the easiest things you ever did in Algebra 1 was counting slope, right? And if you can show me that the opposite sides have equal slope by counting the slope, you can show me it's a parallelogram, right? Because if the opposite sides have congruent slope, then it's parallel, which means it's a parallelogram. So that, I think, is the best way. I wanted to make sure we talked about these because we are going to do those things just later on. But the easiest way, I think, to show that something is a parallelogram is to show that the opposite sides are parallel. And we're going to do that using the slope. So if the opposite sides have the same slope, we are saying it's a parallelogram. Okay? So we kind of already did that here with this one. This is up 2 over 5, right? So that is 2/5. So this slope is 2/5. I'll switch my colors here so we can see that better when I write it in. So this slope right here is up 2 over 5. You can count this slope up to 1, 2, 3, 4, 5, 2/5. Okay, so right there, by just showing 2/5 and 2/5, I've shown you that those two sides are parallel. So therefore, it's a pair of parallel sides. And then we just have to do it again. So do it for A to D and B to C. And counting the slope is a lot easier than distance formula or midpoint formula. So 1, 2, 3, 1, 2, 3. So down 3 over 3, which just is -1. And then the same thing for B to C. It looks like down 3 over 3, which is also a slope of -1. Okay, now I know that seems very simplistic, but again, what we're going to is not just proving it's a parallelogram, but proving that it's a rectangle, a rhombus, or a square. So we just have to get this introductory piece out of the way so that we can build on that later on. Okay, so I have a worksheet for you, so I'm going to grab that. And if you have questions